hearing what we have to say. This is what we said. If you disagree, that's fine. We want to be shown where we're wrong. Hopefully we are. Well, hopefully we're not. But in any event, what I want to do is talk about some things I think are going on, particularly as this relates to Delaware, and some things you should be aware of that maybe you aren't aware of. One of the things I want to start with is something that keeps coming up over and over again. This is a letter you've probably heard a lot about, but don't really know what's in it. This is a letter written to me on February 17th of 2007 by the then Governor Ruth Ann Minner. And this is back when I was a state climatologist. And she says, particularly recent media coverage of events associated with the subject of climate change has generated some confusion about the role of the state climatologist and whom the position represents. She went on to say that in light of my position, due to confusion surrounding your role, I am directing you to offer any future statements on this or other policy on behalf of yourself, the University of Delaware, and not a state climatologist, but I understand that you have not provided your opinions as such. In other words, it was not a slap on the wrist. In fact, I'm the one who started the discussion with her as to what was going on, because a number of people thought I was going to be fired by the then Governor Minner, which I wasn't. But my point is that it continues to be mislaid, because there's an article out there that says that Minner said that reports of my work with private groups, apparently CRI and other groups, and privately backed publications disputing climate change had generated some confusion, and I'll let you decide as to who the culprit was for generating confusion based upon what she said. But on to what we see now. Preparing for tomorrow's high tide, the sea level rise vulnerability assessment for the state of Delaware. You're probably aware the Sea Level Rise Advisory Committee has established a number of things through DENREC, and in particular including people from state agencies, local governments, citizen organizations, business organizations, and environmental organizations. Guess who's missing? Very good. Scientists are missing. Why are scientists missing from this discussion? Because if you look at the first part of the paper and you look at the policy, it says it is a position of DENREC that sea level rise is currently occurring and will continue to occur at an accelerated rate due to global climate change. In other words, the science is settled. We've already decided on that. Now what do we do from there on out? And I also want to point out the date is January 27th, 2010. They decided to look at three scenarios: a sea level rise of 1/2 of 1 and 1.5 meters by 2100. And it says these values shall be adjusted as the Intergovernmental Panel on Climate Change and other peer-reviewed publications produce updated scenarios and modeling techniques. And I stand to hold them to that. So let's see what we find. Here's the sea level rise scenarios. As you can see, the 1.5 meter sea level rise is about 5 feet. For those of you that still work in the old English system, about 3 feet for 1 meter sea level rise, and a little over 1.5 feet for sea level rise of about 1/2 meter. If we continue on sort of where we've been going globally, we're going to get somewhere around a foot. Of course, Dr. Soon is talking about problems associated with even that estimate, but that gives you sort of an idea as to where we're focusing with the sea level rise. And I want to ask the question, is this a scientifically reasonable approach, or is it political science masquerading as real science? I'll go back several years. This is an article that came out in the paper in October 22nd, 2006. It says the blue line would be Delaware's shoreline if global warming causes sea level rise 2 feet in the next 100 years. Let me zoom in on Sussex County. Most of you are from Sussex County. 2 feet sea level rise, that's what the problem would be. What is the normal tidal range? It's about 6 plus or minus 3 feet. So this is what we look at now, apparently high tide. Does Dewey and Rehoboth and Lewis all disappear in our Millsboro, Milton, and Milford, our new seaports, at high tide? No, that clearly can't be 2 feet. I know that Delaware's flat, but it's not that flat. All right, what it turns out is this is really 20 feet. So I show you a map of 20 feet, and I tell you it's a rise of 2 feet. It took about 1.5 years before this was finally corrected. Secondly, let's suppose you are a concerned citizen and you write to Senator Carter. And this is essentially what you would get, is a letter from him saying he is concerned about sea level rise and this map. Any idea what sea level rise that corresponds to? Well, there is no legend on it. Funny thing, because if you go online and find the same map, you can find the legend. And the legend says it's 15 meters, which is a sea level rise of about 50 feet. In that case, Sussex County is all but a memory. The interesting thing is, if you start reading online, it says at the end of this century, assuming continued large CO2 emissions, we are committed to melting Greenland and possibly the West Antarctic ice sheets. And that's not what's going to happen by anybody's stretch of the imagination. And we conclude these data that prevent these amounts of, to prevent these amounts of sea level rise. What do? We reduce CO2 emissions with a few decades, not simply a century. We need to act now because to stop sea level rise means addressing climate change. The two are inextricably linked. Because of climate change, sea levels are rising. We're getting more hurricanes, we're getting more tornadoes, more storms, and so forth. So these are the kinds of things we can stop if we address climate change. So sea level, in Delaware at least, is our segue into climate change mitigation. This also appeared several years ago. The ocean could rise more than 35 feet for each 1 degree increase in global temperature. I read that and thought about that for a minute and said, my goodness. Model projected warming for doubling of CO2 is about 3.6 Fahrenheit to 8.1 Fahrenheit. Chad Tolman estimate, therefore, at 35 feet per Fahrenheit is rise in sea level is somewhere between 126 and 284 feet. To get 284 feet of sea level rise, we would have to have 3 feet of sea level rise per year from now till 2100. 126 is still more than a foot. Why do I bring this up? I made a presentation, you have to be in the audience, and I asked him later, were you correctly cited? And he said, yes, but it just won't all happen at once. The reason I point this out is this gentleman was on the Sea Level Rise Committee, correct? Yes, he was on the Sea Level Rise Advisory Committee. He has advised the governor on climate change issues, and to my knowledge, at least as long as when I was state climatologist, neither governor, the past governor, the present governor, ever asked for the opinion of the state climatologist. Interesting. So, what are the facts regarding Delaware? In this case, we have 2 recording stations that we measure regularly. This is Lewis, Delaware, and again, from 2100, our forecast is a sea level rise of about 11.1 plus or minus an inch, and for Reedy Point, it's 12 plus or minus 2.3 inches. So we're talking somewhere around a foot of sea level rise. But the problem is, it's not, as Dr. Soon mentioned, it's not largely due to rise in sea level, it's largely due to change in land surface. Here you can see we're located at the edge of the Laurentide ice sheet about 21,000 years ago, and without getting into a geology presentation, you can see here when the ice sheet removes, places along the edge start to show subsidence, and in particular we are glacial outwash, so things compress. If you've ever asked yourself the question, why is New Orleans built below sea level? The answer is it was not built below sea level, but it was built on areas that were essentially above sea level, and then the ground compressed as the flooding was no longer allowed to contribute. Same thing here. We've got coastal areas that have been compressing over time, so we have coastal subsidence to deal with. This coastal subsidence is particularly large right here in our region, as you'd expect from the geology. So you can see sea level rise, in this case from Lewis, 3.5 feet since 1900, Reedy Point, 5.5 feet since 1900. And in particular, sea levels have been continuously rising. The use of tide gauge records is complicated by contributions from changes in land level due to glacial isostatic adjustment, simply meaning the land is subsiding in this case. And in this case, we see the increasing rates of 1.7 millimeter per year in Delaware. So what's literally happening is the land is sinking. If we're going to address carbon dioxide, you're not going to stop the land from sinking. Okay, it's not going to have any impact there. So what's really going on with sea level change? Well, it happens to be there's this study by Virginia IMS, which is Virginia Institute for Marine Science. It is the Chesapeake Bay, but nevertheless, similar region. They did an analysis for several stations. Here, for example, is Hampton Roads. Once you adjust for land subsidence, what happens to sea level rise since 1970? Virtually none. You can see effects of El Nino, changing ocean water temperatures and so forth, give you fluctuations, but no long-term signal. How about at Baltimore in Fort McHenry? Same thing. Once you adjust for the sea level, or excuse me, for the land subsidence, sea level rise essentially disappears. Now, we keep hearing this claim, sea level rise is accelerating. Sea level rise is accelerating. You saw that claim made by DENREC, that was their policy. And it comes from a number of places. I'll give you an idea. Noah C. Grant says the rate of sea level rise is accelerating. Copenhagen Diagnosis, a left group said satellite and tide gauge measurements show the rate of sea level rise is accelerated. The U.S. Climate Change Science Program, there is strong scientific consensus that climate change is accelerating sea level rise. The Pew Center on Global Climate Change. So it is now apparent that sea level rise is accelerated over the 20th century. The Royal Society, there is increasing evidence of continued and accelerating sea level rises around the world. Must be true because all these groups say it. Except, these aren't scientific studies. What does the science say? What does the refereed articles, particularly which DENREC said they would use to determine changes in their scenarios? Here's Douglas in 92. Thus, there's no evidence from an apparent acceleration in the past 100 years that is significant either statistically or in comparison to values associated with global warming. 5 years later, they came back. No acceleration during the last century has been detected. Church et al. in 2004. With the decadal variability of computed global mean sea level, it is not possible to detect a significant increase in the rate of sea level rise over the last 50 years. Jevrija et al. In 2006, we showed that over the last 100 years, the rate that occurred between 1920 and 1945 is likely to be as large as the 1990s. Woodworth, 2006, no definitive long-term acceleration of sea level has been identified using 20th century data alone. Holgate, 2007, mean rate of sea level rise over the period of 1904 to 2003 was greater in the first half of the period than the latter half. The difference in rates was not found to be significant, and the last 20 years of the record were not particularly unusual. It just goes on and on. Here's Woodworth et al. Again in 2009. Little evidence has been found in individual gauge records for ongoing positive acceleration of the sort suggested for the 20th century by climate models. Houston and Dean in 2011. We extended analysis of Douglas by an additional 25 years and analyzed revised data from Church and White and obtained sea level decelerations similar to those from U.S. gauge records. Watson in 2011, and this just goes on and on. The analysis reveals a consistent trend of weak decelerations. Chambers et al., 2012, we find there's a significant oscillation in a period of around 60 years in the majority of the tide gauges examined in the 20th century. Okay, so there's lots of variability. So I ask again the question. These values shall be adjusted as the IPCC and other peer-reviewed publications produce updated scenarios. Well, let's see what the IPCC actually said. Here we have the first assessment report. And I'm going to put 4 curves in here. This is the current rate of sea level rise. This is our 1/2, 1 meter, and 1.5 meter sea level rise targets. This is the first assessment report in 1990, and you can see the upper limit is huge, way off the chart. Maybe 1.5 wasn't high enough. But the second assessment report came out in 1995. And the upper limit was now less than the worst case scenario that DENREC is planning for. The third assessment report came out in 2001, and now it's even less. The fourth assessment report came out in 2007. The summary for policymakers looked like this, and the actual scientific assessment look like that. We're not even to the lowest level of assessment. And people ask the question, why is this number for policymakers and the scientific data different from one another? The answer, of course, is that one is produced by policymakers, one is produced by the scientists, and they don't necessarily always agree. One would assume that the summary is the cliff notes of the science. It's not. So where do we get these scenarios? They come from two papers written by the same people, Ransdorf in 2007 and Vermeer and Ransdorf in 2009. So why are they so different in the Intergovernmental Panel on Climate Change? And the answer is simple. We propose a simple relationship. For those of you who understand statistics, read linear regression. We propose a simple relationship linking global sea level variations to global mean temperature. In other words, we've got a relationship between mean temperature and sea level rise. We apply that to the models. That gets us a value of sea level rise, and we conclude that that's the value we get. Houston and Dean actually addressed this specifically. It said our analysis do not indicate acceleration in sea level U.S. tide gauge records during the 20th century. Instead, the records show small decelerations consistent with a number of earlier studies. The decelerations we obtain are opposite in sign and 1 to 2 orders of magnitude less than the accelerations required to reach sea levels predicted for 2100 by Vermeer and Ransdorf. If you were going to base this on science, would you use 0.5, 1, and 1.5 meters? Well, here's the other problem. This is a study done just last year, looking at essentially the climate models and the forecast. And the problem is, particularly you'll notice in the inner Delaware over there and the outer Delaware here, what we're seeing is that the model rate of sea level rise is much faster, oftentimes by almost an order of magnitude faster than the observations. So the idea is the models do particularly poorly in the mid-Atlantic region. So Vermeer and Ransdorf's estimate, while global, the worst place you can apply it is in the inner and outer Delaware Bay region, which happens to be where most of us call home. Well, the fifth assessment report's due out. So the idea is, what do they say? Here's 4 scenarios. The green scenario is sort of what they hope for, that we will address carbon dioxide at the plateau. Then there's blue, red, and finally, blue, orange, and then finally the red one. And if I give you the sea level rises corresponding to the various colored curves, there you have it there. And again, I'll put in our 1/2, 1, and 1.5 meter sea level rise that we're planning for. They're off the chart. In other words, the sea level rise by the IPCC is nowhere near that. So, as Dr. Soon has shown, the natural sea level around the Delaware Bay is rising at a rate of only about 3 inches by 2100, and there's no real sign of acceleration. The acceleration is important because that would imply as CO2 is increasing, we can link it to CO2. And in fact, we can't. We're not seeing an acceleration of sea level rise. What happened in North Carolina? Turns out they did the same thing. This was the North Carolina Coastal Resources Commission, the Science Panel on Coastal Hazards. Their sea level rise assessment report issued in 2010. They had 3 scenarios. They had a scenario here for 0.38, one for 1 meter, and one for 1.4 meter sea level rise. Sort of like ours. The top 2 are a little bit extra. And you can see that sort of if you take the current value and you extend it out, that sort of gets you to the low end of sea level rise. So I'll ask you a question. Why duck? Why is this based on duck, North Carolina? I think you know what's going to happen. Because when you actually go look at the data, duck, it turns out, has the highest rate of sea level rise observed. But it doesn't have really that long a record. We had a much longer record in Wilmington, North Carolina. Why did they not use it? Because the rate of sea level rise is half that it does. It already starts off with less sea level rise. So you pick the worst case scenario and build from it. Can carbon pollution in this case lead to enhanced sea level rise? There's carbon dioxide. We really don't see that in Wilmington, North Carolina at all. So the conclusion was, and signed into legislation was, that this is rejected because of unscientific extrapolation of future sea level rise. And the whole report was thrown out. We need to do that here. Why is there such a focus on sea level rise in Delaware? Of course, you know, we're a flat state, we're low flying, we're a coastal state. If we were Montana, I would be giving this talk, but we're not Montana, because it's all about climate change. Here's from the University of Delaware, showing the University of Delaware research on sea level rise, and it says right down here, it's due to concerns about climate change, extreme weather, rising seas, and what may lie ahead, which is a new normal, whatever that means. But I'll give you something you probably haven't seen, and I'll ask in a moment how many have seen this. This is DENREC, a Secretary Order number 2010-A-0039, issued November 9, 2010. The effective date of the amendment is December 11, 2010. So it's been in effect for over 2 years. It is called Prospective Incorporation. And it says, thus, any supplements, amendments, and any other changes including, without limitation, repeals, or stays that affect the meaning or operational status of a California rule brought about by either judicial or administrative action adopted or otherwise noticed by the state of California shall be paralleled by a similar change to the Delaware regulation, so that the Delaware regulation will have the same meaning and status as its California counterpart. In other words, we are 3 counties now in California without representation in their House and Senate. How many people have actually knew this? Okay, good. There's more people informed than I thought there might be. But I'm not going through all of them. But I'm going to show you a number of what these regulations mean. And so you can see the whole list goes on and on and on. Why are we doing what California adopted? Do we want to do what California adopted? We should have our own decision. If we decide we want to do what they did, fine, but it should be our decision and not the decision that is automatically made by the California legislature for us. What's happening? Here in January, we learned Delaware announced it has hired a nationally recognized expert to help develop detailed projections for changing conditions along the state's coasts, our farms, our cities, and suburban neighborhoods. National expert from Delaware? No. National expert is Dr. Catherine Hayo, Director of the Climate Science Center at Texas Tech University. That's in Lubbock, I believe. It will fill the knowledge gaps that Delaware officials face when planning for anthropogenic climate change. Why did we go to Catherine Hayo? She has done similar work in California, Chicago, and the Northeast. We are going to pay her $46,000 for state-specific work expected to be completed by draft form this year. For 2 months' worth of work, she gets $46,000. I don't even know if she's ever been to Delaware. But how are you going to understand what Delaware's problems and needs are by simply working in Texas and not understanding what's going on here? At the very least, why did we get somebody local to work with her? I don't know. I wish I had answers. I don't know. But here's the key word. Cahill has pointed out that climate models, including past estimates by the United Nations, have systematically underestimated rates of change. It's not fast enough. You've got to act because everything you've ever seen from here about climate change is an underestimate. It's going to happen faster. 2 guesses what her report's going to say. Well, this is interesting. This came out actually just yesterday. Yale 360 group asked her a question. Says, Dr. Hayo, have you seen sizable increases in average temperatures that could be defined as climate change? Her answer, what we've actually seen, at least in West Texas, is an increase primarily in winter temperatures. Our very cold days are getting less frequent, and our winter temperatures are increasing in nearly every station we look at across Texas. Okay, winter temperatures increasing nearly every station across Texas. That should be a testable hypothesis. So let's go collect data from Texas from December, January, and February and see what it looks like. And there you have it, from the National Climatic Data Center. From 1896 to 2013, the trend could not be any flatter. And I don't care if you want to look at the whole record, look at the last 50 years, or the last 40, 30, 20, 10. There isn't a trend in there. She's saying it's all underestimated. I don't see a trend. She apparently does. This is what we're going to be in for. So, there's a couple messages I want you to think about. First, there's no clear sign of acceleration of sea level rise, especially in Delaware. Most of what we see is going to be due to coastal land subsidence, which isn't going to be addressed by anything that has to do with carbon dioxide, methane, or other greenhouse gases. The third is that there's no empirical basis to support anything greater than a half-meter rise in sea level by 2100, and not even sure that would be an extreme scenario that we would want to consider. And fourth, addressing CO2 emissions, which is the whole goal of the game anyway, cannot affect sea level rise in Delaware. What really changes us along the coast is coastal erosion. We've seen Senator Carper talk about how we used to be able to go way out there and now it's eroded quite a bit. Yes, that's erosion. That's a natural process. It's not sea level rise. What we have is a problem where Delaware's coastlines change. Why? Because the coasts are dynamic and variable. If you want to look at where the Cape Henlopen Lighthouse is, where it used to be, I should say, it's offshore. Why would we have it offshore? Well, it wasn't offshore when it was built. It was built on land. But it's not sea level rise that causes that to sink. It's natural erosional processes. This is what we're going to have to deal with as Delawareans. And it's going to come when hurricanes, nor'easters, and other tropical storms come up the coast and affect our climate. Okay? That's when we get the biggest erosion. That's when Bethany gets the biggest erosions. That's when potentially the seashore gets the biggest overwash and so forth. We've got to figure out what do we want to do there. We have to have a discussion of people living along the coast. Should they be responsible? Should we be responsible? Should we replenish beach sand? Should we give up and retreat? That's the question we really need to be addressing. It is not, let's stop climate change, let's deal with carbon dioxide. Because I can tell you, anything we do in carbon dioxide is not going to make hurricanes, tornadoes, nor'easters, all of those kinds of things disappear. They're not going to disappear. They're still going to be with us, and they're going to create the biggest disruption to Delmarva, and we need to address that. Same kind of thing, folks, flooding. The important message, and I'm hoping that this is where, when I turn it over to Rich, that he follows through, which I know he will. The idea is, if you go home and you say, wow, that was an important lecture, or I didn't like it, or whatever. If you said, yeah, that seems interesting, and you never think about it again, we sort of wasted our time here tonight. The idea is you really need to start talking to other people about what the state is doing. You need to start talking to legislators, to county councilmen, to people at DENREC, to people that make the decisions at Bethany Beach, at Slaughter Beach, at Rehoboth Beach, and so forth. You need to really start that dialogue, and if the state won't start it, we need it from a grassroots effort. In particular, we need to get the word out. Some of the things that are going on in the state isn't where we should be spending our focus. And that's where I think you come in. Hopefully you can help us spread the word, get the idea out, so that we make better choices about environment stewardship than trying to worry about climate change and sea level rise over the next 100-some years. Thank you very much for your attendance.
Folks, I'm going to make a command decision here.